our first star of the show today. And guys, this is not any regular speaker. If you guys use DynamoDB and you don't know who this guy is, then there's definitely something wrong going on. Guys, please meet Alex DeBrie, the author of the DynamoDB book, an AWS data hero, basically the DynamoDB legend. So, Alex, thank you so much for being here. Thanks for taking the opportunity to share your insights. How are you doing today?
Absolutely. I'm doing well. Thanks for having me. Big fan of Scylla and all that you do at Scylla and also with P99 Conf, which was probably like, some of the best videos I watched last year was P99 Conf stuff. So looking forward to this year's as well.
Yeah, no, great. And I hope you liked my introduction to you. I mean, I hope I spoke
That's
to.
probably a little too much, but there's a lot of good other, the DynamoDB team and the work they do. That's where it's at. But thank you, I appreciate it.
Yeah, no, you are definitely a legend. You deserve all the credits as well. You contributed so much. But yeah, I know that you also helped actually AWS writing technical documentation for Dynamo, right? But I mean, we can definitely discuss that later on in the round panel. And I think I'll just leave you now, Alex, and I will simply let you amaze us with your presentation.
Cool. Thanks a lot, Felipe. Yeah, looking forward to it. Thanks everyone for coming. I have 30 minutes here. My goal here is just to get you up to speed on all things Dynamo pricing, really like how Dynamo pricing works, how you should think about it, how you can save money on your DynamoDB bills. But before we do that, I just want to start off talking about like why I love DynamoDB's pricing, because I think Dynamo is a unique database and that extends to its pricing. I think it's pretty different and unique in terms of how Dynamo bills compared to other databases. So just a few things about DynamoDB's pricing. Number one, it's predictable, right? When I say predictable, I mean able to reason about it in advance. And in the past, when I've worked with relational databases and developing a new application, I think it's difficult to understand, hey, how much database am I going to need when I go to production or 6 months down the road, a year down the road? I think it's really hard to reason about your costs there. But as we'll see with Dynamo, it's a little more predictable, right? Where if you have a sense of like, hey, this transaction is going to cost or this sort of operation is going to take, 2 write units and 4 read units or different things like that. You can understand, hey, if I scale that to 1,000 of these a day, 10,000 a day, 1,000,000 a day, how much is that going to cost me? And I think you can ballpark your costs in some sense there. So you have some ability to reason about your costs before building. I think also more importantly, you can see the impact of changes, right? So if you go into production, you say, hey, my costs are too high, like what's going on there? You can look at it and sort of say, hey, what if I made this change? And you can really see the impact of that change in a pretty predictable way. So I like that predictability around DynamoDB. The second thing about DynamoDB's pricing is that it's flexible. Again, right, like with the traditional databases, you're provisioning some sort of instance size, maybe a cluster size, and it can be hard to adjust that to your traffic. So you're really provisioning for peak plus in some sense. And then, a lot of the day or even a lot of the week or month, you might have really low utilization on that. But with Dynamo, you can scale your capacity up and down to match traffic. You can do that throughout the month, throughout the week, throughout the day, pretty much as you want, which is pretty amazing that you can do that. Additionally, Dynamo has different modes, different billing modes, different storage class modes, and you can switch between those as well. And the great thing about all this is there's not going to be any downtime, right? You're still going to get that world-class Dynamo reliability and availability. I'd say, probably the highest in the world for any like really high managed service like that. You're going to get that even as you're sort of scaling your capacity up and down or changing your billing modes, which is nice. Last thing about Dynamo pricing is there's a nice tight feedback loop between what you're doing with Dynamo and how much your bill is going to be. And I really like that. I think it teaches you a lot, right? So it's easier to understand what's driving your costs because you can look at your bill and understand like, hey, is it this particular index that's doing a lot of writes or this that's doing a lot of reads, and understanding, hey, what access patterns are using that? Is that still working for me? You can adjust as needed. Maybe you don't need that index anymore. You can drop that and actually see that. And the nice thing, as we'll see in this talk, is there's a really tight integration between the resources you're actually using under the hood, like what is that the Dynamo service needs to do for you, and your costs. I think they've lined up the billing model pretty well to show you, hey, these things have costs, and make sure you're getting the value from that. So we're going to talk about that as we go into that. So I think the high level point here is like Dynamo's pricing should change how you build applications, how you think about applications and what you're doing in there, and help you understand all that a lot better. So with that in an introduction in mind, let's do a deep dive on Dynamo's pricing. 3 big things I want to cover today. Hey, first, why I love Dynamo's pricing model. I talked about that a little bit. I want to talk next about just like the basics of Dynamo's pricing and how it works. Like what are the key elements here and what knobs you can turn and things like that. And then we'll look at tips for managing your DynamoDB costs. Who am I? I'm Alex. Felipe introduced me a little bit, but yeah, I wrote the DynamoDB book, which is just a comprehensive guide to data modeling with DynamoDB. I don't work for AWS. I haven't worked for AWS, but I am an AWS data hero and just do a lot of community work around that. I present at reInvent, things like that. I generally tend to talk quickly because I want to like pack a lot in here. So if you need to rewatch this later, you can, or feel free to reach out. I'll be hanging around in the comments and things like that. I probably won't have time to look at comments and questions that are going on during this, but I'll do the best I can to catch up later. All right, with that, let's go into the basics of DynamoDB pricing. And I like to think about this in 3 different levels. First of all, you need to understand the core units that DynamoDB is going to be billing you on. And then once you know those core units, there are a couple macro factors. I like to call them macro factors, things that you set on your table as a whole that sort of affect your billing in different ways. And there's also some micro factors for every request that you do to DynamoDB that what can affect how much you're actually charged or getting billed there. So let's start with the core units, which are called RCUs and WCUs. And I think Dynamo is unique in that you're going to be paying for reads and writes directly rather than for resources, right? So with a traditional database, whether that's a relational database or even a lot of NoSQL databases, you'll be paying for, you'll select an instance which has some package of like CPU and RAM and maybe IOPS, maybe the IOPS, the storage is separate, but you're getting some package of resources, and it's just up to you to like saturate that as much as you can without sort of harming your application in a way. So like finding the balance there. But with Dynamo, you're not going to be provisioning CPU. You're not going to be thinking about RAM, anything like that. What you're going to be built on are read capacity units and write capacity units. And what these are is basically like every operation you do to Dynamo, they're going to chop that up into read and write capacity units. So a read capacity unit in RCU, this allows you to read up to 4 kilobytes of data from DynamoDB. So if you issue a read, you want to retrieve a given user in your application, maybe that user is 2 kilobytes, they'll pull that 2 kilobytes down, they'll divide it by 4 kilobytes, round it up and say, okay, that costs you 1 read capacity unit. And an individual read to Dynamo, that can actually consume multiple read capacity units. So if you want to read a bunch of orders for a user, and maybe that reads 10 kilobytes of data, it pulls down 10 kilobytes, divide that by 4, it's going to be 2.5, they'll round it up. That's going to be 3 read capacity units for that particular operation. Likewise, just with read capacity units, they have write capacity units. These are when you're actually writing, updating, deleting, any sort of data manipulation in Dynamo. Same concept here, but that's going to be for every 1 kilobyte of data written. So, right, if you want to update that user record that's 2 kilobytes, that's going to cost you 2 write capacity units. So RCUs, WCUs, I like to call those the operational costs of DynamoDB. You're charged on operations. You're also going to be charged on storage, just how much data you have stored in Dynamo. And that's going to be priced similar to, a disk volume or, blob storage or something like that, where they're going to charge you per gigabyte a month of data you have in there. Now, one thing I really like about Dynamo that's kind of different is that billing is mostly independent from performance. So the way I like to think about this is I look at a chart, and on that x-axis, you have concurrent queries. How many concurrent queries am I making to my database at a given time? And then on the y-axis, you have your response time. And I would say a lot of databases that are instance-based databases where you have just CPU and RAM and things like that, you're going to see a performance chart like this where, hey, for a long time, you can just make more and more concurrent queries and your response time is going to be pretty consistent and predictable. But at some point, you're going to saturate the resources on that. Maybe you're, using all the memory and you have to sort of spill the disk or you have IO wait or whatever it is. You're saturating that. And now you have this much longer response time for your queries. What used to be fast is now slow. With Dynamo, it's going to look more like this, where your performance, your response time is going to be flat. It's going to be predictable, sort of regardless of how many concurrent queries you have. And this doesn't mean, hey, you can issue as many queries as you want against Dynamo, but if you hit that point where you're querying more than you've paid for or than Dynamo can handle, they're going to throttle you back. But that's going to be a quick response time on that throttle. We're going to say, hey, you haven't paid enough for this, you haven't provisioned enough for this particular second, so wait a second, come back later on that sort of thing. And I think that's pretty nice. If you look at that curve where if you saturate and it really goes off, I think if you look at distributed systems literature and things like that, if you read the tail at scale from Google, or just different thoughts on tail latency, this is really hard to deal with when you're talking about your P99, P99 conf here. This is what we're talking about here. When it really tails off, your performance tails off like that can be difficult for your application. It can be difficult for your application's client that are going to your database. Maybe you have timeouts set and you're cutting off that timeout, but that's still tying up resources in the background, you're retrying and having some issues. Or maybe, the clients that are actually calling your service that are then calling the database, maybe the clients that are calling your service have their own timeouts. They're reissuing that request and queuing up more requests there. So this can be difficult to deal with as compared to that more predictable flat line. So I like that, billing is independent from performance. You're going to get that same consistent performance regardless of, if you're sort of over exceeding what you've paid for. All right, so there's the just core units of Dynamo. RCUs, WCU is going to be the big one, and then thinking about storage as well. Let's talk about the macro factors a little bit. And what I think about for macro factors are like, hey, what are some things you can do in the AWS console essentially to affect your DynamoDB bill, right? So Dynamo has a couple different modes for you. Again, remember we said your Dynamo bill is mostly going to be operations, your RCUs and WCUs, and your storage costs. That's going to be the bulk of your DynamoDB bill right there. So in terms of operations and how you charge for operations, they have two different billing modes for you with DynamoDB. The first one, the traditional one, is called provision throughput, right? Where you are setting some set amount of WCUs and RCUs that you want to have available, and that's going to be available to you on a per second basis. So you can say, hey, I want 2,000 WCUs, 10,000 RCUs, and that's how many read and write requests I can make per second against my database. If I exceed that, then they're gonna throttle me back. If I don't use it, it's pretty much use it or lose it. So you're not gonna get those back if you don't use them, other than a little bit of like saved up burst capacity for that sort of stuff. But generally, just a typical use it or lose it type thing here. But in addition to provision throughput mode, they also have an on-demand billing mode where you don't set how many RCUs, you don't set how many WCUs you want. You just say, hey, I have this table. I want to be on demand. I'm going to issue read and write requests against that table. You calculate how many read and write units those cost me. At the end of the month, you're going to charge me those per million, right? And it's basically like, in your cheapest regions, it's going to be a quarter per million RCUs, and $1.25 per million WCUs, something like that. So in that one, you're not sort of having to think about how much capacity do I need. You're just saying, hey, you handle that for me and send me the bill at the end of the month. Now, in addition to this billing mode that you can change, you can also choose a storage class for your table. This is a little more recent, but basically what they're doing there is kind of like blob storage, S3. If you look at the different storage classes they have there, with Dynamo, you can say, hey, I want a storage class where I'm doing a lot of operations against my table. I want my operations to be cheaper, but my storage will be sort of comparatively more expensive. Or if you're saying, hey, I have a lot of historical data around, I'm not doing as much operations comparably. So let's actually save money on my storage and charge me a little premium for my operations. That's basically what you have there. So the standard table class, that's going to be cheaper operations, but more expensive storage. There's also standard IA, infrequent access, very similar to S3 here, where you have cheaper storage, but then more expensive operations. So these are, things you can do on the macro. What can I set on my table to sort of manipulate how my bill works, different billing modes, different table storage classes. With that in mind, let's go into the micro factors and what's happening on an individual request I make to DynamoDB that either cost me more or less read and write capacity units. So I like to talk about what I call the multipliers. What are the RCU and WCU multipliers, right? Because if I'm issuing a single request to Dynamo, it's not like that's going to consume one write capacity unit, one read capacity unit. It's actually going to do potentially more based on other things I'm doing. And the biggest factor you need to look at there is just your item size, right? A read capacity unit allows you to read up to 4 kilobytes of data. But if you have a read that returns 400 kilobytes of data, that's 100 read capacity units you're going to be consuming there. So you need to think about your item size for something like that. Also, you can do a thing called secondary indexes on your DynamoDB table, which basically it sort of like makes a copy of your table just with a different primary key, allows for different access patterns. But because they're making an additional write there, you need to pay for that write as well. So you're going to pay for that secondary index in addition to your main table. DynamoDB transactions. So this is a feature that came out 5 or 6 years ago now, where you can get some of those ACID transaction-like features if you need to be working on multiple items in sort of an all or nothing type way. You can do that with transactions, but it's going to cost you twice as much as those operations would be if you weren't doing them in a transaction. Global tables, this is another cool feature where, basically you can set up your DynamoDB table to be in multiple regions, and every write you make is going to get replicated out to those other regions for you. Very nice for being close to your users, maybe for disaster recovery reasons, but it's also going to cost you for those additional writes. Consistent read. So Dynamo, every item in your DynamoDB table is going to be replicated across 3 different storage nodes. One of those will be the leader, but when you make a request to DynamoDB, by default, it's just going to choose one of those nodes at random, which means you could have a slightly out-of-date read and eventually consistent read there. If you use eventually consistent reads, you don't opt into consistent reads, they'll actually give you a 50% discount on your RCUs. So if you were reading that user record that was going to be 1 RCU, it actually costs you half an RCU, which is pretty nice there. You can choose to do a consistent read and force that to go to the leader storage node, but then they're going to charge you the full read capacity units on that. And then finally, as we get sort of deeper into the API, there are a couple different ways that you can retrieve multiple records in a single request with Dynamo. There's the query operation, which basically gets a set of contiguous records from a single storage node and returns those to you. There's also a batch get, where you just specify a bunch of different keys you want to get. Maybe you have to go to all these different storage nodes to retrieve that. And query is going to be a much cheaper, more efficient one as compared to batch get. And so as we look at these multipliers, there are all these different ways that, hey, a request that you make to Dynamo, it can be more expensive or can consume more units. And what's going on here is we talked earlier about that tight feedback loop. I mentioned there's a tight integration between the resources you're sort of using under the hood and the cost that DynamoDB is gonna give back to you. So if you look at all these different multipliers, the thing I like is Dynamo is indicating to you some sort of expense that you're doing and sort of, incenting you to, use those judiciously so to be more efficient, right? So we talk about item size. Larger items require more resources, right? If you're writing larger items, it might take more pages on disk that you need to write, different things like that. It takes more memory to just hold those, to buffer those in memory, different things like that. If you add a secondary index into your table, that's just more writes you have to do, not just in your main table, but also for each secondary index, you have to write that across 3 different storage nodes, and that costs money. Transactions. Now we have coordination across lots of different nodes. We have to do 2-phase commit, lots of different network requests there. So, that coordination can be helpful, but it also costs, and they want you to realize that. Global tables, hey, great feature, but they have to maintain that replication infrastructure, replicate across region, not only do that right, but have the infrastructure and conflict resolution and different things like that. So they're going to charge you a premium for that. If you want to do a consistent read, well, now you have to route specifically to the leader. That might mean a cross AZ read. There's some network bandwidth that's being consumed there. It's also just like putting more load on that leader. So they want to make sure that you're using that properly. And then query and batch get, right? It's just batch get requires requests to more storage nodes, which requires more sort of network bandwidth and throughput and different things like that to make that happen. So anyway, with all those things, I think the nice thing about that, again, Dynamo is sort of indicating to you, hey, these features are available, these things are available, but they do cost more, and make sure you're sort of getting the value out of it, right? I think they're really like making that linkage apparent to you, which I really like. So those are the basics of Dynamo pricing, right? We have our core units, RCUs and WCUs being the big thing there. We have our macro factors. What can we do at a table level to sort of manipulate our pricing? And then our micro factors, what can we do there? Let's now switch gears and look at just like managing Dynamo costs. And what tips do I have for reducing your DynamoDB bill, both, if your table's already in production or if you're like moving into a new Dynamo project? How do I sort of think about these different things? And I have 3 tips here. The first one I say is mind your multipliers, right? And if we look back at sort of those micro factors, the different multipliers we have, is just look at all these things and make sure you're getting the value from the multipliers that you're using there. So I think the big ones I see is hey, first of all, review your item sizes carefully. I see a lot of people just throwing all sorts of data into an item and not really needing it or using it. So if you don't need those attributes, don't put them on there, right? Like you don't need to save that data to be thrown around all the time. Just forget about it altogether. If you have large attributes on your records, compress those before you write them to DynamoDB, or better yet, send them to S3. You don't want to save a profile picture in your DynamoDB record. That's something where blob storage is really great for something like that. So if you have large files or just large blobs generally, like S3 can be a more cost-effective way to do that. You can also reduce your attribute names. So Dynamo is a schemaless database, which means it's got to maintain its schema with every item in it. It's got to, it's not charging you just for the attribute values, but also the attribute names that you have there. So, you can shorten those attribute names to save bytes, which can really make a big difference if you're talking about billions and trillions of items. And then finally, in some cases, you might want to split items if needed. And the example I have here is, say you have a large item, let's say a 10 kilobyte item that has one small attribute, maybe a counter or an updated at field or something like that you're updating quite frequently. If you're updating that frequently, every time you're going to pay those 10 WCUs to update that entire item, where it might be better to sort of split just that updated counter out. So then when you're updating that, hey, you're only paying that one WCU to update that little value, and you can fetch that whole record together when you actually need both sets of the data. So that's one tip there, is just review your item sizes carefully. Another one is just limit secondary indexes, right? I think a tendency I've seen with relational databases for sure is just like adding indexes just to be sure, and then people have tons of unused indexes. But that can happen with Dynamo as well, right? Where they put these indexes in advance and just in case. You don't really need to do that. You can add secondary indexes later on. Dynamo is going to backfill that for you, and don't do that. So really think like, hey, do I need this index? Because a write might be 20 times more than a read, right? Because not only is an RCU 4 times bigger than an RCU is 4 times bigger than a WCU, but also WCUs are generally about 5 times as expensive as RCUs. So writes are significantly more expensive than reads. So make sure you're actually getting the benefit of that secondary index. Another trick you can do is use projections to limit the size of your items in your index. So by default, it's just going to copy your entire item into that secondary index. But you can say, hey, I actually don't need all that data for my secondary index access pattern. I just need a few of those items. So you can just say, hey, just project these items into that index. And what that's going to do is save you on write costs when you're writing to that index, also save you on read costs when you're reading lots of items from that index. It can really reduce that for you. Another one is limit transactions. I think, transactions was a great addition to Dynamo, but now you see people just overusing them and using them for a lot of things they don't need them for. I say lean into sort of NoSQL modeling and understand that. Use transactions where you need them. I like to use them for sort of high value but low throughput operations where, hey, maybe you have some dependencies between these or some conditions you really need to make sure are matched across different items, and that's a great place for transactions. But if you have higher value or sort of higher throughput and higher contention transactions, that's where the bill's going to add up, and you're also going to get just contention issues as well. Global tables. Hey, it's a great feature, but make sure you're actually using it. I see a lot of people sort of theoretically adding global tables for regional failover type reasons. Make sure you have all the supporting infrastructure in place to make that happen. Dynamo is a pretty reliable service, and if Dynamo goes down, do you have the supporting infrastructure to fail over your compute, your DNS, whatever else you have going on to make sure that you can actually take advantage of Dynamo in another region? If you're just doing it for backup and disaster recovery or something like that, hey, Pitter and backups, those are better for that. Last one, maybe controversially, is I'd say in most cases you don't need consistent reads. I think especially with how Dynamo's model works, you don't really need that. We don't have time to really go into that right now, but if you guys want to fight about that later, I'm happy to. But I would just say, don't opt into that consistent read. Take that 50% discount on RCUs and be happy with it. All right, so that's the first tip. There is just mind the multipliers, right? Think about for these individual operations you're doing to Dynamo, how can I save some money there? The other one I say is you should regularly audit your usage, and this is especially on those macro factors you had before. Again, you can be changing this stuff all the time, so make sure you're sort of still be efficient with your usage there. So we talk about auditing your usage. You should really be looking at your billing mode and make sure you're doing well there. In terms of choosing a billing mode, remember we have the 2 different billing modes. On-demand mode costs 6.94 times as much as fully utilized provision capacity. So basically 7 times as much as fully utilized provision capacity. Now, the key there is that's fully utilized. No one is getting full utilization. If you go look at your relational database right now, I bet a lot of the time it's sitting at like, 3 and 4 and 5% CPU utilization. So you're not getting anything good like that. But basically what you need to do here is throughout the month, you need to be hitting 14.4% utilization or better for provision capacity to then be cheaper than on demand. So look at that. I'm not saying it's not doable, but I would say sort of the best customers I see are usually going to be 40, 50, maybe 60%. I think that's with like pretty stable stuff, pretty dialed in auto scaling, things like that. I think it's hard to get, really high utilization on that. So make sure you know what you're doing there. In terms of just like advice, my advice on how to approach this stuff, I would say use on demand until it hurts, right? On demand is nice. Like, again, it's giving you 14.4 utilization on average. You don't have to really worry about it. That's your bogey. Make sure you're at least hitting that. And I have people come to me and say, hey, how do I save money on my Dynamo bill? And their Dynamo bill is like $50 or $100 a month, something like that. And it's like, hey, you should be using on demand and not thinking about it, because you have an engineer spending 2 hours on that. That's already spending more than your DynamoDB bill. So make sure you're actually getting value if you want to dial it in. When you go to provision, I think every month you should be making sure you're hitting 14.4% utilization. That's very easy to calculate just using the metrics from the AWS console. So just, hey, set something up to run that calculation, make sure you're hitting 14.4% utilization. And if you're not, switch it to on demand and be happy with that. Dynamo does have auto scaling, so it can auto scale with your traffic as you start to hit higher utilization of your stuff. I think as with all auto scaling, make sure you're using it with caution. Like, it's not going to auto scale immediately, so you need to sort of dial that in. If you have quick spikes in traffic, it's going to be tough to keep up with that. So make sure you know what you're doing there. And then you can explore reserve capacity, right? Where you pay in advance for a year or 3 years of capacity. Right now, if you do reserve capacity for a year, I believe it saves you like 50%. So already that's getting you down to like 7.2% utilization in order to beat on demand. So you can look at that as well to help save money. So that's the first one, audit your billing mode. Same thing you should be doing with your table storage class to make sure you have the most efficient table storage class. Again, there's a pretty easy calculation to figure out which table storage class you should be doing. Basically, we talked about operations and storage, and basically you should be indifferent between the table storage classes whenever your operations costs are 2.4 times your storage costs, right? If that's the case, you should use either storage class. It doesn't really matter. But if it's greater than 2.4%, if you're using comparatively more operations than storage, you should be using the standard storage table class there, because that's optimizing for cheaper operations rather than storage. On the other hand, if your operations costs are less than 2.5 times your storage costs, then you should use standard IA because you want to optimize for cheaper storage. The one thing I'll say here is standard storage is almost always going to be cheaper at first. If we just run the math there, if you write a kilobyte of data to Dynamo, that costs about 5 months of storage, right? So if you write an item to Dynamo, that first month's storage cost is only going to be 20% of what it costs you to write it. So at the beginning, standard storage is always going to be more expensive unless you're doing like import from S3, which doesn't cost you rights there. But this is going to shift over time, right? As you start to accumulate all this extra data and have sort of comparatively fewer operations compared to this, giant amount of data that you're also holding around. Now, that's when standard IA starts to get more attractive. So make sure you're continually running these numbers. This is a very easy thing to set up automatically to just calculate at the end of every month and say, hey, should I switch this, right? Another thing here is, maybe you don't need to keep around all that data. So Dynamo has a TTL type thing where it'll automatically just expire data once it gets past that TTL. If you don't need to keep data around, don't keep it around, don't pay for it. TTL doesn't charge you for the write, so it actually saves you a bunch of money there. And then you also don't have this extra data that you're paying storage on. All right, so those are the big two that you should be auditing your usage. Again, these you should set up. You can have automatically do this and just say, hey, is my billing mode effective? Is my table storage class effective? Again, changing these will not affect the operation of your DynamoDB table, which is great. Another thing you should do regularly is just review your secondary indexes and making sure you're getting value out of them. Like, first of all, just like look at your secondary index and see if you have any secondary indexes with 0 reads on them in a month. And if that's the case, you're paying for a secondary index that's not giving you any value. You should drop it because you're just paying for a bunch of writes. And then, even if it has some reads, what's that read to write cost ratio on my secondary index? And if that starts to get out of whack, you say, hey, are there better ways to handle this than using a secondary index? And sometimes, sometimes you have a secondary index that costs you a lot in writes and you don't use it for many reads, but you need to do that sort of thing. But I think looking at those secondary indexes and just making sure they're still giving you value is a good habit to get into. All right. So again, mind your multipliers at the micro level, audit your usage at the macro level, and just run the numbers. I think when you're building with DynamoDB, as you're operating DynamoDB, you should be running these numbers. And I really think that Dynamo's pricing should change how you build applications. You should start thinking about these things of just like, hey, how much would it cost if I did it this way versus this way? I think it starts to build a really nice muscle that works not only for Dynamo, but it works for your compute. It works for S3. It works for, hey, if you're choosing between different sort of async solutions like Kinesis versus SQS versus something else, I think like just building that muscle of understanding, hey, how do I think about cost in my application and all that sort of stuff? I think that's great. I really love, again, how Dynamo using those multipliers shows you what's expensive and why you should get charged for it in your database. I think other databases don't do that. And this like helps you build that muscle for other databases as well. So I really think it should change how you build applications. And yeah, that's the world we're in through DynamoDB costs. I hope that was useful to y'all. Feel free to reach out, keep in touch. Like, got my email here, got my Twitter here. Like, happy always to talk. I'll be hanging around in the comments and things like that if you want to chat. But otherwise, yeah, thanks for sticking around.
Wow, that was great, Alex. Thank you so much for such an insightful presentation. What you mentioned about global tables, I think it affects pretty much every database out there, which of course supports multi-region deployments, right? Every now and then we see people like hey, I have this primary data center, this primary region, and the secondary one, and then when they try to do some sort of disaster recovery, nothing works because they haven't architected their entire infrastructure to fail over everything, right? Do you see that very often?
Now, yeah, I mean, I see people asking about global tables, and I just say, hey, make sure you really have that. I was actually listening. I think AWS has a case study on this, but I'm not sure, so I won't say the company. But there's some company using, I believe, Aurora that they actually like fail over. They do like a follow the sun failover. So like as their customers wake up in different regions, they just fail over to different regions. So they've obviously got it like dialed in to where they're regularly exercising that muscle and can fail to another region. But I see a ton of people that just like set up global tables, pay for the global tables, and if an outage ever happens, I doubt it would actually like work to
actually work.
So just make sure you're like actually getting the value from that sort of thing.
Yeah, no, that totally makes sense. All right, so I have tons of questions, but I will save all of them for our panel at the end. Alex, thank you so much.